We are going to start the second part of our event. And we have, and we had this morning, presentations about the different case studies, cities experience. And we learned that we needed to use more data, more beauty, more action in terms of our environment. And right now, I'm going to invite to speak an architect, a landscape architect, professor, that use nature-based solutions. And this is a very important thing that we need to take in consideration today, because the environment is doing some signs that something is not good. But today, we are going to watch a very interesting project, and in fact, something that's happening. So it's my pleasure to invite Ebru Ozer to the stage.
Hi, everyone. My name is Ebru Ozer. I'm a professor at Florida International University and co-founding principal of LandscapeDE. The work I will be presenting today is developed together with my partner, Douglas Thompson. My presentation will focus on nature-based playground design. I will start by introducing the nature-based playground concept, show early examples of nature-based playgrounds from around the world and United States, share some of our work at LandscapeDE by utilizing the playgrounds we designed for Miami-Dade County as case studies, and finally conclude my talk by discussing the role nature-based landscapes play in creating sustainable, resilient, and smart cities. Modern life has significantly transformed the traditional nature-based experiences many of today's adults enjoyed during their childhood. Many of the existing playgrounds in our cities often feature fixed, predefined structures that limit children's ability to use their imagination during play and offer little room for exploration or to connect with nature. While they comply with physical safety requirements by minimizing risks and reducing liabilities, their uniform, standardized, and quickly consumable characteristics often lead to them becoming boring quickly. According to the National Wildlife Federation, recent research indicates that when children play and learn in natural settings, they exhibit more enthusiasm, engagement, imagination, and cooperation when compared to wholly artificial environments. Additionally, exposure to nature reduces symptoms of attention deficit and depression. Nature-based playgrounds promote physical fitness by encouraging activities such as climbing, balancing, and running, and help build confidence through risk-taking and overcoming challenges in a natural setting. They can also function as outdoor classrooms, facilitate nature-based education by providing a direct connection to the natural environment. Children who grow up playing in nature are more likely to become environmental stewards as adults. The history of nature-based playgrounds can be traced back to the concept of junk playgrounds of the post-World War era. These innovative playgrounds were first introduced by a Danish landscape architect, Carl Theodor Sorensen, in the early 1930s. They were playgrounds modeled on the empty neighborhood lots and featured materials like tires or other junk, allowing children to build and create their own unique play areas. Adventure playgrounds follow the junk playgrounds movement. The Notting Hill Adventure Playground you see here, founded by Lady Ellen of Hertford in 1960s of London, and was the first of its kind and still stands as a pioneering example of innovative playground design that prioritizes creative play. Adventure playgrounds encourage free play and include materials with loose parts and more naturalistic play elements that allow a greater amount of risk-taking for children. Huntington Beach's 1979 adventure playground in Berkeley, California, is one of the first examples of adventure playgrounds in the United States. The Alexander Camp Adventure Playground at Cambridge Commons in Massachusetts mimics a natural landscape complete with hills, valleys, wooden branches, and stumps. It features like sand and water play provide children with opportunities to engage with the park's materials, ensuring a new experience with each visit. In 2014, the first nature-based playground in the United States was opened in Portland, Oregon. This play area was a part of a pilot project for a nature-based play initiative, a program designed to curate a stronger relationship between children and their natural environment. The playground includes scalable log towers, a stream channel with water pumps that children can manipulate, large sand areas, and stacks of loose woods which children can fashion into huts and hiding places. Our firm, LandscapeDE, has the privilege of working with the Miami-Dade County Parks, Recreation, and Open Spaces Department to develop the initial concepts for nature-based playground designs in Miami-Dade County. Since 2015, we have been actively involved in designing playgrounds for the county. To date, we have successfully completed 3 nature-based playgrounds, and we are currently in the process of designing 4 additional ones. Our hybrid approach to nature-based design concept not only combines natural play elements with traditional playground equipment, but also generously incorporates South Florida's native plant palette into the design. We aim to reduce heat exposure through natural canopy and dense subtropical foliage. We also integrate heat-resilient play elements and play surfaces and significantly increase children's and parents' exposure to South Florida's native plant communities to foster improved environmental awareness and stewardship. Our nearly decade-long experience in developing nature-based playground design concepts served as a significant foundation for Miami-Dade County's nature-based playground design criteria booklet, which now serves as a template used to guide other landscape architects in designing nature-based playgrounds for the county parks. What is a nature-based playground? It's a playground that connects children with nature, where natural elements seamlessly woven into play. They encourage free, imaginative play and provide safe opportunities for risk and challenge. They can be composed of natural elements and carefully selected traditional play equipment. Some of their benefits include helping children develop environmental awareness and feel more connected to nature, fostering diverse play and building confidence, and improving collaboration, sharing, negotiation, problem solving, and empathy skills. Some great examples of nature-based playgrounds are found in Europe. In this Denmark playground, the play space is a series of vegetated mounds traversed with paths incorporated with steps and slides. One intriguing aspect of this playground is that children creatively shape the play space through their use, forming paths and altering the landscape over time. Another example from Denmark showcases different elevations connected by terrace slopes. At the base of the slope, there's a broad sandpit with 3 stumps and stones, providing opportunities to practice balancing. Remarkably, this playground has been in existence for over 20 years, and not a single child has suffered from a serious injury during this time. In this Australian example, we witnessed the seamless integration of climbing, jumping, and rope play challenges, all of which contribute to building children's confidence. In the United States, we observed similar experiments involving the combination of natural elements with traditional play equipment. Here in Westmoreland Park, the primary focus is also on climbing and balancing activities. Typically, playgrounds in our parks are distinct and separate entities. Playground equipment combinations are chosen and the necessary safety surfacing is applied. Both the equipment and surfacing can be quite costly, reaching thousands of dollars and purchase for installation. More appealing equipment can even drive budgets well beyond $1 million. Trees, plants, and natural elements are often considered secondary, seen as obstacles, and perceived as maintenance challenges. This Manhattan's Teardrop Park exemplifies the incorporation of local material and provides adventure and sanctuary while engaging both and children. This is a playground that, how I mentioned, about $1 million, maybe, perhaps, but it doesn't connect children to nature. This is an example of a high-budget playground, likely well over $1 million, where all of the time and money was seemingly spent on equipment and safety surfacing. Bringing nature into play requires placing it as a priority in design. The interactions can be simple, but they require attention at the forefront. A great way to start is looking to natural places as inspiration. The composition elements in local nature can be brought into play spaces. This is a play area in Pathfinder School in northern Michigan. The campus of the school is within a forest. The play area are very simple in their designs and construction, and play is immersed in nature. Play elements are not built in a way that pushes aside nature. The boat structure on the right is distinct but also subtle, built amongst the trees. Also, the play here allows incorporation of natural elements as seen in the constructed stick fort built by children on the left image. This is a great example of what nature play should strive to be. Of course, not all proposed play areas have such a great wealth of natural elements to rely on. Many playgrounds in suburban or urban locations require more careful consideration of the site and its natural elements. For this project, we selected a playground site within a park where there were a good number of live oaks that could be incorporated into the play area. With additional elements, this site could be transformed into a more naturalistic settings. In our approach to nature-based playground design, we have a list of considerations we bring to each project to create connections to nature. By drawing inspiration from natural places, our playground designs seeks to create immersive experiences within nature, incorporating nature-inspired play elements, non-play site elements, and opportunities for risk, all within an extensive circulatory space that allows children to move through and explore with freedom, complemented by a nature-focused planting design. To begin with, we look at natural spaces that are rich in beauty and biodiversity. Regional nature parks and preserves are great places to scout for materials, forms, and ideas. In South Florida, a live oak hammock has a lot of interesting and unique forms to draw ideas from. Pine rocklands are also a unique ecosystem in our region that has many elements that inspire our designs. Nature-themed equipment are not an adequate substitute for nature. Often the forms are generic and inauthentic. Instead, we seek to immerse, play within natural spaces. Our design for Kendall Indian Hammocks Playground was created to harmoniously blend the park's existing trees into nature. In addition to incorporating the existing live oaks, we added native plantings throughout the play area to enhance the sense of nature. Similarly, our design at Camp Metacumbe Playground brought in a lot of new native plants to create a new, unique space with a natural context. Along with an immersive environment, we try to build natural elements into the play space. For our design at Biscayne Shores and Gardens Playground, we utilize recovered cypress sinker logs to create a unique play element. Similarly, at Camp Metecumbe Park Playground, we took the idea further to create a small obstacle course that encourages both play and exploration. This naturally hollowed cypress sinker log not only provides an opportunity for intimate nature experiences, but also encourages curious players effectively. Native oolite stone is a significant geological element that we aim to incorporate into play areas here in Miami-Dade County. This stone underlies most of South Florida, emerges at the surface in various locations, including along the Miami Rock Ridge and in the Everglades. It also makes appearances in our playgrounds, sometimes serving as benches or surfaces for jumping, climbing, or hopping. Earth forms also play a crucial role in our playground designs. Hills offer opportunities for climbing and sliding and serve as vantage points for surveying the surroundings. To enhance these features, we add natural elements such as native planting and boulders. There are multiple ways to scale this hill at Camp Metecumbe Park Playground. For adventure seekers, we have oolite blocks of various sizes, just a bit larger than a child's step, offering a structured climbing option. For those seeking a slightly easier climb, there is a rock scramble route. And then there are just ways up there are invented by children. Water is also a great natural element that children love. Rather than utilizing a conventional splash pad, our approach involves creating play spaces that emulate natural water contexts and movements. At Pioneer Park, children will have the opportunity to alter the course and movement of flowing water. Offering children opportunities to modify and customize their play experiences and engage in experimentation aligns well with our goals of nature-based play. Sand play areas are also great places for children to modify their environment and experiment with. Along with play structures, other elements can also enhance the nature play experience. At Kendall Indian Hammocks, we utilize Australian pine logs as both benches and informal play elements. Australian pines are invasive species that are gradually being removed from the Miami-Dade County parks. We repurpose logs from some of these removed trees, which will naturally decompose over time, offering children the opportunity to observe a natural process not in traditional playground environments. We use local stone boulders as benches, which are also informal play elements. We appreciate witnessing nature thrive on our design elements, enhancing our naturalistic design approach through its subtle organic modification. Another key element of our approach to nature-based play is the integration of expansive circulation. We don't view the playground solely as a place for play equipment, but a space for movement and exploration. Multiple pathways and alternative routes enable children to explore the space. The entire design may not be immediately apparent upon first glance. The freedom of movement also creates opportunities beyond focused play elements, allowing for spontaneous games and alternative uses of space. There is ample room for games such as tag, follow the leader, and hide and seek, all of which can be read from the plan view of Camp Metecumbe Park Playground. Opportunities exist for movement throughout the play area and also in and out of it within a visible and safe context. Creatively designed play elements can also be part of the circulation, such as the obstacle course at Camp Metecumbe. Pathway connections in play areas can also be part of the play. In this new playground at Cherry Grove Park, we are creating alternative paths through an existing stand of trees, which will be at the center of play experience. Plants are also essential components of our designs. We are quite generous with our planting and make every effort to secure sufficient funding for securing the plants for our projects. We design plant communities by thoughtfully integrating native species and pollinators to establish essential native habitats that attract native insects and bugs, butterflies, all while creating beautiful landscapes. We feel we are successful when we observe abundance of wildlife. Rather than using many numbers of the same plant, we carefully increase the number of species to ensure plant diversity, just like how it is in the nature. In addition to attracting wildlife, our planting design also looks natural and remind the users about nature. In our built playgrounds, we observe bees, moths, and butterflies. Butterflies include zebra longwing, gulf fritillaries, and monarchs, birds like blue jays, cardinals, mockingbirds, and owls, and mammals like possums, raccoons, and foxes. Our forms are also inspired by nature. We often create hammocks. We layer our plants to allow for unexpected growth, mirroring nature where plants compete for their place within the forest. This creates a mosaic of texture and color that supports a thriving ecosystem. Not all native plants are suitable for high-intensity play areas. We prioritize durability by selecting plants that are not easily trampled or damaged. It is also essential that the plants give the appearance of being difficult to walk through. For instance, saw palmettos, slash pines, and silver palms have a sharp appearance that deters damage, although they are not actually sharp. Additionally, we avoid using toxic plants. Natural shade is an excellent way to integrate nature into play space and immediately foster appreciation. Additionally, native shade trees can offer significant habitat and food for birds, insects, and small animals. Live oaks, for instance, support hundreds of other plant and animal species. In addition to their shade benefits for humans, the trees establish a direct connection between the play experience and nature in numerous ways. Sometimes very few trees exist on the site. In such cases, allocating a budget for trees become a top priority for us. Most of the trees in this image were introduced on the site, including large live oaks on the left. Maintenance is an important part. Plant selection plays a role, but also communication with maintenance workers. Plantings can be significantly weakened and then trampled with the wrong maintenance. Effective communication of the concept to maintenance personnel is essential. The trimming scenes in this instance occurred following a change in contracted maintenance crew responsible for trimming at Camp Metacumbe. New York City now has numerous parks in Manhattan and Brooklyn with thick and naturalistic vegetation that feels safe and well maintained. This type of naturalistic maintenance approach is on the rise in our cities. We employ them too. Equipment is also a key consideration. We prioritize using natural and simple materials whenever possible, avoiding loud colors and forms that might shadow our natural context. Color is used sparingly. Key equipment selection considerations we employ include prioritizing space over equipment, considering equipment maintenance, and leaving enough budget for plants. In addition to their effectiveness in nature-based playground designs, we discovered that these strategies are also valuable in the design of other playground types. The primary focus for our Pinecrest Garden project was an inclusive design with a colorful theme. However, we found opportunities to introduce nature-based play elements into design. We created tree-shaded play spaces that incorporate natural elements and local ecology for an immersive experience. We also incorporated expansive circulation to enable free movement and exploration. Connection to nature is not something you simply hear about or read. You need to see it, feel it. Just like the mesmerizing sight of Mexican free-tailed bats emerging from the Congress Avenue Bridge in Austin, not only serving the essential purpose of hunting insects and mosquitoes, but also providing remarkable moments for people to feel deeply connected to the wonders of the natural world. As Timothy Beatley contends, if the connections between cities and nature are evident, then individuals are more likely to understand their personal connection to it. As architects, landscape architects, planners, it is our responsibility to make these connections visible and evident in our designs to more sustainable, resilient, and smart future. Thank you.
Now we are going to have a panel, and we are going to put 4 chairs here. Our panel is moderated by Marilys Nepomechie, Distinguished University Professor, School of Architecture, Florida International University. And we have also Biayna Bogosian, Assistant Professor, Architectural Technology School of Architecture, Florida International University. Sara Pezeshk, Postdoctoral Fellow School of Architecture, Florida International University. And Thomas Spiegelhalter, Professor, School of Architecture, Florida International University. I'm waiting to put the chairs here. 4 chairs. I'm supposed to put. Where are the chairs? Let me see here. Unfortunately, the guy is not here. Let me look here outside.
The chairs are coming. Great. Thank you, sir. Oh, well. Get out of your way. Thank you very much. Okay, we're ready. Yes. Okay. Sure, I hope so. Yeah. Hello. Is this on? Yeah. Okay. Thanks, Ebru. And this yes. Okay. I'm not sure how this works. Bernardo, how do we advance the slides? have any idea how to advance the slides? There we are. Okay. Perfect. Thank you very much. So good afternoon, everyone. My name is Marilys Nepomechie, as Bernardo so graciously introduced us. What we'd like to do today is talk a little bit about, in the context of a really exciting and I think very important conversation about smart cities and about resilience, how we at Florida International University are in the process of training, educating, conversing with, encouraging our students to design in ways that create a more resilient and ideally smarter city. I'm here this afternoon with three absolutely brilliant colleagues. We share, you just actually heard from another one of my wonderful colleagues, Ebru Ozer, and you'll hear tomorrow from Elisa Silva, also on our faculty. So FIU is well represented at this conference today. But this particular group of people is together at this moment because the four of us share responsibility for teaching a graduate course on sustainable design, a Graduate Design 9 course. It is a moment in the professional curriculum of architects at Florida International where they are challenged to design a building, a landscape, and an infrastructure that are net zero in their impact on the environment. It's a tall order. It is one that not only looks at processes and methods and materials for designing and building, but really looks forward to the potential impact that the decisions that an architecture student and ultimately an architect can make might have on the built environment as a whole. But my colleagues, in addition to being wonderful professors and inspirational ones for their students, are also active professionals and scholars engaged in extraordinary research. And I'm going to ask each of them to please speak a little bit about the work in which they're engaged, and then later we'll all speak about how they bring that research and that work, professional and academic, to their work with students. So I will turn the floor first to Biayna Bogosian. Some of you may have heard her speak earlier today. Dr. Bogosian received the MSAAD from Columbia University. She is an assistant professor that focuses on architectural technology at FIU, and she'll be speaking about realignments and toward a critical competition. Following her, and I'll just do all the introductions now and then they'll step up, is Dr. Sara Pezeshk. And Sara is the inaugural graduate of the DDES program at FIU, the Doctor of Design. She holds the MTech from the Architectural Association in London, as well as a professional degree in architecture from SCIARC. And she is currently a postdoctoral fellow at FIU. And finally, Thomas Spiegelhalter, who is on the verge of having his doctoral degree from the University of Genoa. He said he's turning that material in next week. Dr. Spiegelhalter is a full professor at the School of Architecture. He is also a practicing architect and in Germany and in the United States. The projects of his practice have been built all around the world, and he brings the scholarship of his academic practice into actual fruition in his built works. It's a wonderful pleasure to speak with all of them, and I'm going to turn the floor over to Biayna. Thank you.
Thank you so much. It's an absolute honor to engage in a panel with my esteemed colleagues. And today, I will build on what I begin to cover in the morning, and with the aim to expand on the computation and computational design specifically. If I can have my presentation, I will begin. So my official title is I'm an assistant professor of architectural technology, and what architectural technology is really starting to look into how to combine architectural design practices with computational design. And the computational design is an emerging new field, and it looks at relationship between computer science and design. So with that, we're starting to look into how incorporation of computer science technique, computational thinking, could allow us to make better design decisions. And as my earlier presentation highlighted, I'm very much interested and invested in applying tools and finding methods that we can engage the public with environmental data. Now, that's a lot of words, but what really is at the center of my interest is to find ways that we can begin to look into relationship of society and technology, and along with that, begin to tackle this complex sustainability issues that we're here to look into. Now, my colleagues would, with their presentation, specifically talk about the incredible work that they're doing with rigorous merging of computer science and environmental science. Professor Spiegelhalter will talk about how a systematic way of applying tools, in this case, it could be perhaps Autodesk tools or interoperability, could really allow us to do calculations and be accountable to the outcome of our designs. And Professor Pezeshk will talk about how combination of material research and robotics could allow us to find new tools and ways of engaging. And Professor Nepomechie will talk about how incredible way of including the society and teaching as a part of creating discourse would allow us to tackle sustainability in a sense and really educate generations and generations of architects that are then becoming a part of Miami. But here I want to maybe step back a little bit and maybe talk about makeup of this panel, but who's part of this conference. So if I could go to the next slide, which I guess I could do as well. So very much part of my work is looking at participation. So in this case, it's not just about looking for creating tools of participation, but at the end, looking into who's participating in the approaches and the technique and the system that we're putting in place. And with that, I want to introduce a term here, which is critical computation. So critical computation is a study of theoretical, political, and ethical ways that computation is being applied for us to do decision making. Maybe you've heard of AI and ethics. Maybe you've heard of different ways that we're starting to think about how our decision making perhaps should be more systematic. Maybe we should be accountable for not only data that we're collecting, but also how we're using the data. And this term critical computation, I would like to put it forward as a way for us to continue discussing it in the context of net zero. So it's not so much about using tools and approaches for us to arrive to that number zero, but also who's participating in these conversations or ways that we're arriving to that zero. So in a sense, who's engaging? So it could be people like us, but who's deciding that we can take a day off and participate in a conference like this? And what's our accountability after we leave this conference room? So if we were to think about critical computation, this is my way of summarizing perhaps 4 different principles or key components that we can put forward. So critical computation could be a critical analysis of computational systems and technologies. So look at the relationship between surveillance, type of data that we're using, existing infrastructure. Somebody mentioned the big tech earlier. So really, what are these existing systems that are allowing us to operate? The second component could be development of new computational tools and methods. So it's not so much about, well, is Microsoft releasing the next tool? Is Google releasing the next tool? But what are ways that we could also begin to, through hacking, some people love that word, some don't, but how can we actually begin to engage with creation of new tools? And start to think about participatory design, participatory research, participation in general, and at the end, I am highly, highly advocating for interdisciplinary research, and I will show an example of interdisciplinary research. I want to highlight a conference that I was part of. So in architecture, this field of computational design, we have a conference, an organization called Association of Computer-Aided Design, and this year we celebrated the 42 years members of this collective. So for the past 42 years, we have getting together as architects, as technologists, and thinking about what is really relationship of computation and design. And these conferences, which are happening in rooms like this, often this conversation don't really travel that far. But what was really critical as a board member of Arcadia and as somebody who co-organized to really think about this idea of realignment toward critical computation. So in this case, we created, this happened during the pandemic. So as you can imagine, the cover of the proceeding, it reflects all the texts and all the communications back and forward that we sent. But along with this, also, we created an archive, and archives are really important. Earlier, I talked about environmental data archives, but whether it's a conference like this or we're committing to collecting data, archives are really critical. So archives are of our promise to the future. We might not be knowing what we're doing right now, but by collecting information and by committing to sharing them, we're promising to next generations, to our colleagues, whoever's outside this room, that we are accountable for what is being discussed here, but also we are perhaps optimistic for the future. I think that's why most of us are here. So what I want to quickly highlight here is we started to look into, as part of this conference, data, and this data was who funded this organization. So in this case, we're really grateful for Bernardo for putting us together, but who else is part of this, right? Who are maybe people that are working behind the scenes and organizers, and how can we, by knowing their names, expand this conversation? But also, what are some graphical decisions that we're making for us to highlight certain things, celebrate technology? And these are proceedings from 40 years of this organization. And along with that, I want to arrive to this. We committed to sharing what is being discuss in a conference that could be like this, so dissemination, but also where are these conversations taking place? So in this case, are we always talking about New York and Miami, right? If we're always comparing Miami to New York, if New York is the future that we're striving for, are we really making progress? So in this case, looking into where these conversations are taking place, but also who is in the position of being invited to these conversations? What is the gender balance of people that are organizing these conversations? And at the end, what is then the gender balance that people that are being awarded for participating in this conversation? We talked about mayors and others that might be invited to be inaugural fellows or get awards, but really, how are we looking at different information? And if we are only awarding, in this case, if you look at the progression, I think it's quite obvious what the disparity here is, but also who are the keynote speakers. So I think today we have a really healthy balance, but if these are the keynotes, then what happens to the attendees, right? So in 2020, 2021, due to pandemic, when we opened the conversation, you could see how gender balance also changed. So along with this, I am pleading that as we're talking about data, as we're talking about future of computation, smart cities, etc., but who are making these decisions and who is being invited to the table? So as somebody who's advocating for participation, making tools, etc., making sure that information is accessible, transparent, and we are really thinking about, as much as possible, engaging people is critical. Now, that takes me to teaching. I'm going to talk about a very specific short example here, which is an EPA competition that for the past few years, professors Ebru and others have been participating at FIU. So in this case, it's an EPA Campus Rainwork Challenge that we participated with students. And this was an example of bringing architecture students with landscape students, but also with civil and environmental engineering to participate in a competition. This was not part of my course assignment. This was an independent research that we did as part of that, and I just want to share a few minutes of this, and then with that, I'll return to my seat. So in this case, we proposed that, we did a survey of a campus community on FIU's BBC campus, and we realized that we're severely lacking gathering areas, but also students had a very little awareness of what was happening to health of the Bay, but also the ecosystem in hand. So what you see here is a video of our research process and findings.
The Marine Academy of Science and Technology, or MAST, is a magnet secondary school located on the Biscayne Bay campus of Florida International University in North Miami Beach. The MAST and FIU BBC experienced significant flooding from tidal events and rainfall. To evaluate the potential for tidal and pluvial flooding, we simulated a 24-hour, 25-year return period for 3 sea level rise scenarios. We learned that the rainwater at MAST is currently diverted to an existing retention pond that infiltrates surface runoff into groundwater via the porous limestone substrate. Our seepage flow model for the retention pond filling and drainage indicated that pluvial flooding will not be a major issue under the 2050 NOAA sea level rise scenario, whereas tidal flooding will cause recurrent problems. Other project aims included addressing the lack of fresh water for irrigation on campus and communicating the volatile health of the Biscayne Bay to the campus and neighboring communities. Additionally, our satisfaction survey indicated that 95% of MAST and FIU students feel that the campus lacks common gathering spaces. Working closely with the MAST and FIU BBC leadership, our solutions considered the 2050 sea level rise scenario and included elevating a perimeter road, incorporating green infrastructures, and installing multi-purpose smart pavilions. Elevating a perimeter road. FIU Storm Surge Simulator shows between 0.6 and 0.9 meter storm surge inundation around MAST building for Category 3 hurricanes. We identified the main access road to the site as the most prone to flooding. We concluded that storm surge associated with Category 3 hurricanes could be eliminated by elevating a portion of the main road by 0.25 meters. Green infrastructures. The proposed green infrastructure includes green roofs for the MAST building and vegetated permeable pavements for the parking lots. The proposed green roofs retain up to 42 inches of stormwater per year that help reduce stormwater runoff. Our heat flux simulation showed that the green roof reduces the indoor room temperature up to 3.5 degrees Celsius. The temperature reduction from the permeable pavement is 3 degrees Celsius to 4 degrees Celsius. Using a SWIM model, we calculated that our proposal increases infiltration by 68%, while runoff decreased by 73%, and total suspended solid loading reduced by 75%. Multi-purpose smart pavilions. These gathering spaces invite the students of both institutions to mingle, socialize, and share ideas. The pavilion's doubly curved geometry is inspired by biomimetic principles to collect rainwater at its base and distribute water to other sections. The pavilion's modular structure uses sustainable materials and techniques. CFD simulations show a wind gust velocity of under 4 meters per second, considered suitable for extended sitting. The pavilions are also a real-time monitoring interface for communicating the health of the bay to the surrounding community. A complementary augmented reality mobile application overlays further information about the water quality and sustainability efforts of the project. We believe that our project, Resilient MAST at FIU, can inspire other coastal institutions to adopt resiliency strategies for living with coastal waters under extreme weather events.
Thank you, and I'm happy to report that we won first prize with our students with this proposal. But I'm hoping that with that, going back to UNSDG data, so if we could find a way that we could look for ways to incorporate data with not only design, but look for also what are our stakeholder gaps. Thank you so much. I want to just put this forward and looking forward to participating in a conversation. Thank you.
Okay. Is this? All right. Hello, everyone. My name is Sara Pezeshk, and thank you for the introduction. I have been teaching and also studying at FIU, Florida International University, since 2015. And here I'm going to be sharing some of my teaching pedagogy that I have been doing since then. Tomorrow, actually, I'm going to be talking about my project more in detail. That's what I did in the doctorate degree that in the past 3-4 years now. The title of my talk is Resilient Built Environment, Performance-Based Design, Material Ecology, and Digital Fabrication, Empowering Designer of Tomorrow. These are the this is the methodology that I have been using throughout my teaching students how to kind of design generative design, which means that it's a holistic design, which comes from schematic thinking of how you can create something performance oriented, that it's not only aesthetically looking nice, but also it's can perform well with the climatic problems, or if you have structural situation. So everything it's from design, which is algorithmically designed with the code, it can get optimized using data. And also looking at material studies, followed by fabrication, which is mostly digital fabrication in this case. So these are the some of the example of students' work that that been actually following these principles of generative design. This is a good example of students tend to look at the biomimicry, which is nature-based, nature-inspired. So nature become as a mentor for students to look into the geometry of their inspiration, and they can kind of look into decoding that, and then trying to do experimental project, which is kind of hands-on project, and then going back to computational and decoding that and using these to kind of getting optimizing with the data that usually it's solar data, wind data, as you can see, and then at the end fabricating. So this is the whole process that I usually teach students to kind of think about everything at the same time, and not just design, but also at the end fabricating. This is a project that it was a pavilion. It was inspired by coral morphology, that it's kind of a lightweight shell structure that you can see the panels are changing based on the size of, depending on the solar shading that it's been analyzed. These are some of the examples that I have of students' work throughout years, looking at how they can use digital fabrication, creating these hands-on experiments, and to kind of understanding how they can create something that it's not a conventional thing, but a smart system, understanding lightweight structure, digital fabrication, and material system. This is last semester. It was done by Arc Aloud. They called designers to come up with a design for floating housing in Miami, Biscayne Bay. So we participated for our studio class, and then the start, of course, we had look into collecting data, teaching the student how they can look for those information. They gather the information in order to kind of design later on and implement it to their design. And again, I was encouraging students to look into nature again. This is an example of looking at a sponge structure, which kind of this specific sponge, it's called basket sponge, that has a very interesting structure, and it works very well with the system that it has, very lightweight, that it can withstand the wave, and actually grows very low in the ocean. So the student looking at the structure of the pattern and kind of implementing that, and how he can use this. He used it as a kind of a grid shell structure, and then using a very lightweight material, which is bamboo in this case, and kind of using fabric to cover these floating houses. And they were actually looking at how this these kind of combination would work in 100 years when the sea level rises. These are different examples, again, looking at different inspiration. One is looking at the lily pad, which is kind of an interesting structure. It can float very well on the water. Another one was looking at mangrove trees, and the last one is actually looking at net system and a spider web. Again, this is another studio that I was actually teaching. It was it's a sustainable studio. We have looked into how we can integrate energy using the program Revit. It's a actually cloud-based program they have called Green Studio, which you can take your design and then analyze it for kind of simulating and kind of understanding how much energy your building is using. So it's a great tool to have it as a kind of a part of a design workflow. And this was actually a project that was for an environmental research center at FIU that they were working on. So again, looking at data and then analyzing the landscape and kind of, it's a kind of iterative process. So they look into the numbers and they kind of redo it and changing something and then study that. So it's a great tool to use for having more efficient, energy efficient, basically, design. This was also another project that we did to make it more interesting. We kind of tried to make a pavilion, like a one-to-one scale. So the students were kind of, it was a group, studio within studio competition. One of the students got selected, so we got to build this one-to-one shell structure, which was kind of, again, looking at biomimicry approach, looking at this, how the cellular packing works, and you can kind of create a very simple structure using a very, something very available material. Here in this case, it's a sisal fabric that we kind of created with this process was very analog, but you can also use other techniques to kind of build this shell. And this is, which it's talking about material system. I'm going to be talking more about this project tomorrow, which it's part of my doctorate project, which looking at how you can look into making more sustainable material. Here I was testing different concrete mixes to kind of make the concrete less aggressive, so lowering the cement ratio and then kind of replacing it with minerals. So in a way you can reduce the cement, which is the part of the concrete that is not sustainable. And then testing it and to see how you can kind of, by changing the materiality, you can absorb more biodiversity by the shoreline. This was another independent research we did with group of students. We got this robot a few years back, so we wanted to experiment with some kind of a fabrication. So we created a project for ourselves, like we called it Breeze Wall. So this is also was an interesting experiment. So we have looking to see how we can kind of create a very a smart kind of interlocking tile system. This was actually being printed with clay and then glazed later, and then attached in a way that they can kind of interlock together. And that was the project we did a few years back with the students. Again, looking at robotic additive manufacturing, I have looked into different material. Here I look into terracotta and then how the terracotta actually is very sustainable material, and kind of you can use these as a kind of a, here I was exploring with how you can it this mangrove pod along the shoreline, and you can kind of attract a different ecological and different organism kind of hosting on these. And this is another project that also, again, looking at these type of fabrication technique. Here I was looking at mainly, again, inspired by natural element here, which is a brain coral that it's kind of using the reaction diffusion algorithm. So I have used this because I thought like it might be interesting because it has also a structure, but as well as it has the because the way that additive manufacturing it's with robot works, it's just a continuous print. So that was a kind of a interesting thing to look into that. So how you can use certain process to design something that it's kind of becoming more efficient. And again, so these are some of the projects that you have done in the past few years, and that's it.
Here we go. So my name is Spiegelhalter, and I'm talking about envisioning carbon positive master plans, green blue infrastructures and adaptive buildings for or in Miami, 2023 to 2100. Thanks to my speakers before.
really more than data gathered or programs learned or academic projects, but it really is this extraordinary responsibility of stewardship that those of us who teach take on. And it's a responsibility to the minds that are lent to us at the length of their professional education, to the professions that we represent and for which we prepare our students, to the communities that those professions really shape.
They take these tool sets and use, if they go on to become a designer or architects later on in their life, they can go, if they work in the firm, they can just insist maybe their bosses to kind of use these tools and implement some of these sustainability innovation and techniques. Because I know I've been there, I know myself, it's not happening in the real world. We learn things when, unfortunately, when you go to the working in a corporate offices, that's not usually how things run. But maybe if you go and then try to show the interest, try to kind of work with your colleagues or show interest and explain the projects, maybe we can little by little make your client or people out there more interested in these things and the importance of how you can design holistically and implement this to kind of help for the next, challenges, environmental challenges that we are facing.
Yeah, thank you. I think for me, it's 3 parameters. The first one is to foster interdisciplinary and computational thinking, and I think that's really critical. Within School of Architecture, we have also department in interior design, but also landscape architecture. And depending on how schools of architectures are set up, maybe you have the luxury of sitting next to a class that's teaching planning or another one that's teaching building science. So this silos that we've inherited from World War II and beyond, sometimes they serve us well, so then we can actually advance research. But in the conversation about sustainability and really beginning to focus on solutions, they're not really serving us well. So trying to foster that is really critical. The second component is actually be able to use the tools. So as what Professor Spiegelhalter showed, these are many different tools with very specific computational requirement that requires hardware and software knowledge. So it's not just about software. It is also about knowledge of hardware. So this becomes really challenging. So teaching our students that when you're installing software, don't assume that the first 3 times it's going to work. Make sure that you know how to troubleshoot, how to ask the right questions. This is really critical, and of course guiding them to the right resources. And the last one is to emphasize actually that these environmental topics that we're covering in studio, they're beyond one parameter, which in Miami that tends to be focused on water. So when I sometimes show my students my previous work focused on air pollution monitoring and visualization, they ask me why air pollution. And that's, for me, it's really tragic that students that in second year we're teaching them how to do flood simulation, they do not know the importance of also looking at other parameters, right? So it's not just about the computational tool, but also communicate complexity of these parameters, which then often comes down to, well, maybe I cannot process the entire county, but maybe I should focus on a neighborhood or, in this case, Miami Beach. So I think playing with these 3 variables, at least for me, is critical. Thank you.
Yeah, I would say intrinsic motivation and critical thinking are the 2 foremost important variables or criteria. Intrinsic motivation also relates to experience, and the nice experience we have at FIU, and I'm sure at UM too, and here at Miami-Dade colleges, it is the most wonderful experience to be in a classroom or a studio where everyone looks different, because then we have the chance, and maybe speaks different languages as well, and comes from different backgrounds. So we can start to share our experiences, how we perceive the environment and our surrounding. And when we can break that ice, then we can go to the next level of critical thinking. But first we have to respect each other and understand we are different. And actually we don't see each other, because whatever we think we see is computed here, between the synapses and the neurons. And that's based on how we, to what kind of childhood we went through. But that depends on the size of the class. No? You colleagues, you agree. No? If we have a 100+ lecture hall filled with students, it's difficult. But if it's a small studio with, let's say, 15, 16 students, then we can get familiar to it. One of my most famous questions is always, I ask the students, close your eyes, or you can even keep them open, but tell me where north is, west and east. And it's interesting, 80% doesn't know where north, east, and west is. In spaces like this, they don't have an orientation. So that's the way we start then to work together.
I think we have a long way to go, but thank you very, very much to my exceptional colleagues for the beautiful presentations. Thank you, Bernardo, for having us here.
Are there any questions from do we have time? No, we don't. No?
I think we need to go. There's another speaker. Thank you.
Yes, ma'am? I give you the microphone. Ah, okay. I can give you mine.
I wanted to ask you, I was glad to see that you were discussing renewable power integration with the buildings. And I'll be speaking tomorrow regarding our energy situation that we're in right now on renewable integration, particularly with EV charging being a high demand in our utilities, not necessarily being able to handle that demand. I was wondering if you guys have considered hydrogen fuel cells and utilizing wastewater and city waste towards power?
Yes. Yes, absolutely. These technologies are already not just beyond the experimentation phase, they're already in place. No? For example, in Germany, the hydrogen train. No? Then we have in South Korea and Japan the hydrogen cars. Mercedes-Benz has hydrogen cars. Then the first hydrogen solar building was built in 1991 in Freiburg in Germany. Solar power and hydrogen. It still works, it's still functioning. And I think we fly to the moon and to the Mars with hydrogen as well. Yeah. It's just, it's like the Matrix, right? Yeah.
Thank you again.
Yeah. Yeah, we need a very good moderator.
Thank you very much.
Thank you.
Great,
Yeah,
great.
thank you
I
so
love it.
much. Yeah.
Bernardo, thank
My
you.
pleasure.
I hope it didn't take too long.
Oh, did we hold the time?
Bon. Now, we are going to have a coffee break, okay? We have a brew machine outside, okay? You can order any kind of coffee, coffee latte, whatever. And we come back 4:30. Ina just arrived from Tel Aviv, okay? Just came from Tel Aviv. She's in the building right now. And she's going to speak at 4:30, okay? Thank you very much. Tudo ali, né? Ladies and gentlemen, boys and girls, this is the way that start in Disney. Used to be. I think they change. We are going to start now. Bom. Now, I have a pleasure to introduce our next speaker. Ina Braverman, she's the founder and CEO Eco Wave Power. She came direct from Tel Aviv for our event. And she's also shortlisted for tonight for the award ceremony. And it's a very interesting presentation because we are talking about innovation. But beside innovation, she has a personal experience that she's going to share with us. So, Ina, welcome.
So, hi everybody, nice to be here. So, I'm here to tell you a little bit about wave energy. I'm the founder and CEO of EcoWave Power, a company that developed a unique, innovative technology for generation of clean electricity from ocean and sea waves. But let me first start from the beginning. You're probably wondering why a photo of me as a child is relevant to wave energy, but it is, other than the fact that I was a cute child. So I live in Israel, but I wasn't born there. I was born in Ukraine in 1986. And 2 weeks after I was born, the Chernobyl nuclear reactor exploded, which was the largest in history nuclear disaster in terms of costs and casualties. I was one of the babies that got hurt from the negative effects of the explosion. My mother approached my crib, she looked down at me, and I was pale and blue and not breathing. I actually had a respiratory arrest and a clinical death. And she ran to my dad and she was like, oh my God, the baby is dead, like what do I do? And he shook her and said, you're a nurse, do something. She was so shocked, she forgot she's a nurse. And then she gave me a mouth-to-mouth resuscitation until the ambulance came and actually saved my life. So I got a second chance in life. I didn't remember any of it because I was a baby, but in all the family meetups and gatherings, everybody would say like, wow, it's so cool, you got a second chance in life. So I grew up with this feeling like, wow, maybe I'm very special, you know, I can actually do something good for the world. But when I was 4 years old, my family decided to immigrate from the Ukraine to Israel, to a super small town in the north of Israel called Akko. You can see a photo here. And Akko wasn't really advanced, like there was nothing there to do as a child, not even like a cinema or a shopping mall, which are pretty traditional in the States. So most of our time as children were spent on the beach. And when I grew up, I decided to enroll in Haifa University. It's a university in the north of Israel, and study political science. And, you know, I had this drive to make a change, and I thought, okay, through politics, I could really like make a big change, make peace in the Middle East, I don't know what, but in a sense of somebody in their early 20s. So I didn't make peace in the Middle East, but we still have time. So when I finished my university, I was surprised to find out that like a young lady straight from political science did not have a lineup of politicians waiting to hire somebody fresh from the university. So I started working at a renewable energy company as an English-Hebrew translator. And although that company wasn't my cup of tea, there I really discovered the world of renewable energy. I discovered about solar energy and wind energy. And whereas solar and wind were packed with competitors, like there was nothing to really innovate in terms of the technology. It was there already for many, many decades and years. Wave energy was something that everybody was super passionate about. All the scientists and engineers said like, wave energy can produce twice the amount of electricity that the world produces now, yet nobody was able to make it commercial. It was too expensive, it was breaking down, no matter how much resources were invested. So why wave energy is so great? So first of all, in suitable locations, wave energy can produce 24/7, around the clock, as opposed to solar energy, which is an amazing source, but you have the night where it can't produce any electricity, you have cloud coverage and winter and so on. Wind energy is also an amazing source, but it usually is dominant early in the morning or late at night, when the population usage is actually at their lowest. In addition, the density of water is 832 times greater than density of air, meaning we can produce much larger electricity amounts with much smaller, thus cheaper devices. And if we're looking here at the United States, according to the United States Energy Information Administration, wave energy alone can produce 66% of all the United States energy needs. For comparison, right now, collectively, the United States, in all its states, is producing only 18% of renewable energy. Still 82% are from polluting sources. And in addition, two-thirds of the world population are currently living on the coastline. With that type of population distribution, the need for wave energy is undeniable because we can save a lot of money on the transmission costs. So usually at this point, the question that is being asked is, if wave energy is that great, why didn't it commercialize? Like, a lot of funds were invested into it, a lot of big shot companies went into that field. Why weren't they successful? And the answer kind of lies in the presentation here before you. This is not our technology. This is a company called Pelamis. They basically took a big red snake, they installed it in the middle of the ocean, and inside this snake was all the expensive equipment, the hydraulic conversion, the generators. So it was too expensive. The construction cost was about $150 million for a power station that can supply about 100 households. So it will never return the investment. Still, investors decided to invest in it because they said, okay, it's starting very expensive, like many other fields, but the price would go down. But Pelamis broke down after 3 days of operation, total loss to the system, 150 million sunk. The reason for that is because in the offshore, you have waves of 20 meters and even higher, and unfortunately, no man-made stationary equipment can survive the load of a 20 meters wave height. Insurance companies saw that it's so expensive and it's breaking down all the time. They were reluctant to insure wave energy, offshore wave energy. And environmentalists, which were supposed to be the greatest proponents of wave energy, were actually objecting offshore wave energy. Because to connect this thing, you need to connect it to the ocean floor, and then you disturb the marine environment, the fish get tangled in the connections, and then it's not exactly environmentally friendly. And another problem was that these companies, they got so preoccupied with trying to lower their cost and surviving that most of them never got the chance to connect to the electrical grid. So there became a big question mark on whether wave energy can even safely connect to a national electrical grid. So what we see here, this is eco-wave power. As you can see, it's a completely different technology and a completely different concept. We do not go into the offshore. We only connect to existent man-made structures, such as piers, breakwaters, jetties, and other types of structures. The only thing in the water are the floaters, which belong in the water, and all the expensive machinery is on land inside a regular shipping container, just like a regular power station. So simple but smart. So how does our technology work? Our floaters are connecting to existing structures, such as piers, breakwaters, and jetty. The floaters are going up and down with the movement of the waves. They're pushing the hydraulic cylinder, which transmits biodegradable fluid into land-located accumulators. A pressure is being built. The higher the wave, the higher the pressure, which is turning the hydromotor, turning the generator, and sending clean electricity into the grid. So the advantages of the technology is that it's cost efficient. Our first grid-connected installation was built in Gibraltar in 2016. This is 100 kilowatt installed capacity, and it cost us only $450,000. In comparison to $150 million, that's a big breakthrough. We're also 100% environmentally friendly because we do not connect to the ocean floor. We only connect to existent man-made structures which already disturb the environment, because let's be honest, cement in the water or stones in the water are not environmentally friendly, but we have to build them to protect ports and to protect coastal communities against storms. So we're taking something that is not prime real estate and that is actually damaging the environment, and we turn it into a source of clean electricity. The technology is also reliable. As we can see in the video in the bottom of the screen, when the waves are too high for the system to handle, the floaters automatically lift above the water level, and they stay locked in the upward position until the storm passes. When the storm passes, they go back into the water and commence operation. And because we're reliable and cost efficient, we're also fully insurable by reputable insurance companies and have been grid connected for 6 years in Gibraltar, and now just recently grid connected our second power station in Jaffa Port, Israel. So here we can see a little bit of our development pathway. We started testing in the Hydromechanical Institute in Kiev in 2011. We were testing different floater shapes to see how the shape influences the actual energy generation. Then we deployed an off-grid, small-scale, 10-kilowatt power station in the port of Jaffa. Back then in Jaffa, in Israel, there was no legislation that enabled to connect wave energy into the grid, so we did an off-grid installation. From 2016 till 2022, we deployed a grid-connected power station in Gibraltar. And currently, as I said, we're deploying our second grid-connected power station in Israel, which is the first time in Israeli history that wave energy officially connected a few weeks ago to the Israeli national electrical grid. So here we can see a little bit of our plans for the future. So right now, as I said, we activated the EWP EDF1 project in Israel. It's a project that we did in collaboration with the Israeli Energy Ministry, which recognized our technology as pioneering technology and funded 50% of the installation. And the other 50% was funded by EDF Renewables IL, a subsidiary of the French national electrical company, Électricité de France. Our next installation is actually here in the US. We'll be in the port of Los Angeles. We already shipped the equipment to the port. We're pending the last licenses in order to actually install it. And then it will be the first, from our knowledge, onshore or nearshore wave energy installation in the United States. And some good news that came from it is that the California legislators, they saw that we're bringing the technology, they saw that it's realistic, they came to visit, and just on Friday night, there was a legislation, SB 605, that passed in California to give a dedicated budget for study and implementation of wave energy. And California became the first, thank you, California became the first state to actually have a specific legislation for wave energy, so we're very excited about it. And our first commercial scale installation is planned to be in Portugal, in the city of Porto. We entered our first commercial agreement for 20 megawatt, which is about 20,000 households. That's already like a big installation for the wave energy field. And we're starting there with 1 megawatt, which is 1,000 households, and we're planning to start construction early next year. And the construction will take 18 to 24 months. And then really, we will be able to show that wave energy is not only cost efficient and not breaking down and easily connected to the grid, but that wave energy can actually become profitable and produce significant energy amount, which is, I feel it's great to be a part of an impact industry, but if something doesn't make money, then it wouldn't really succeed in the future. So the company currently also holds pipeline of 404.7 megawatts in different locations around the world, in Europe, United States, North America, Asia, Oceania, and South America. And recently, the company became publicly traded on NASDAQ in the United States under the stock symbol WAVE, which we worked hard to receive the stock symbol. There was a lineup. So we're very, very excited to be here, and definitely the US is one of the core markets that we're focusing for the implementation of our technology. And why I chose this picture, basically, look, I started from a very young girl from Ukraine that nearly died during the Chernobyl disaster. Then I moved to a super small town in Israel, Akko, that didn't even have a cinema growing up, which is kind of, weird for today. And to be standing there and actually as a CEO of a publicly traded company in the United States, like from a little girl to that, like that's very exciting for me. And I would like to finish by saying that, I always say that passion is the greatest renewable energy source, even stronger than the power of the waves. And I really believe that what I've been through, again, not only from the past experience, but even as a female in a mostly masculine industry, because right now in the energy industry, 95% of the executives are men, only 5% of the executives in the world are women. So many times, opening the company when I was 24, I wasn't taken seriously. I heard a lot of no, I heard a lot of not possible, and still I didn't give up, and I really want to inspire other women and men to really pursue their dreams. So even if something seems impossible, even if you're feeling like you can't achieve it, you don't have the money, you don't have the contacts, you don't have whatever is needed, it's possible, because I didn't have anything, not even the technical background. So. And also I would like to say that although I'm not objective, I'm really a keen supporter of wave energy, I do believe that the solution for all the world's problems are combining all renewable energy sources. So solar, wind, wave, tidal, algae, whatever is coming up, because each source is available during different times of the day, during different seasons. So if we really want to move away from this 18% and make it 80%, flip the ratio, then we definitely need to install and implement more renewable energy sources. Thank you very much.
We have a very interesting, emotional presentation from Ina. And go outside to. Well, it's incredible when you have this kind of, let's say, conversation, very nice, personal. And she came specific from our event from Tel Aviv. It's 13 hours flight. Right now, we have our friend, Carl Welty. He's an architect, and he's going to talk about regenerative, I'm sorry about my accent, regenerative architecture in cities, okay? Please welcome.
Some really great stuff. I really appreciate the practical. Anyway, so to the question of renewable, I'm just to preface here is I'm an old school architect who learned in the 70s and in the 80s that you can make a building envelope itself and design it as an energy system. And that's what I'm going to talk about as well, the regenerative design. So let's get started. So, I'm not very good at this. So I'm going to talk about regenerative design and the importance of working with nature, not resisting nature. By working with nature, we can achieve more energy efficient and more resilient architecture, excuse me, and communities. There are three ideas I want to talk about today, and they're all interconnected. One is drawing inspiration from ancient cities built before our modern technologies and reliance on extracted energy. Ancient builders learned to provide both thermal comfort and water by working with nature. What are the lessons from the past? Incorporating solar-oriented design, ventilation, and vegetation to manage thermal comfort, and capturing and storing water. And two, I want to focus on a particular development located in Northern California, in our California's very hot Central Valley, which this development has successfully incorporated these ancient lessons from ancient history and integrated solar orientation with natural water harvesting designs. And three, to talk about regenerative design, an approach that begins with working with nature to create ecological, low-carbon communities that evolve over time. Dholavira is an archaeological site in western India. This site, like so many ancient city sites, was oriented with an east-west pattern and included a sophisticated water capture and storage system. This 5,500-year-old city is an example of a solar-oriented city grid integrated into the local natural water and flow cycle. And I love it because it's clearly an east-west oriented city that reaches out and grabs the local rivers. I'm not opposed to solar panels and advanced technologies, but I want to talk about they have their place. solar panels and other advanced technologies have their place, but working with nature produces more efficient, more resilient solutions for less cost than advanced technologies. Working with nature reduces our dependence on more expensive advanced technologies. As our planet warms, I find inspiration from ancient cities and how the example of the Mediterranean courtyard, which creates a microclimate that's 10 to 15 degrees cooler than the hot parts of the Middle East in the Mediterranean. And more particularly, this development in Davis, California, that was built in 1975, construction started in 1975, and by implementing these natural cycles and systems, the microclimate of this 60-acre development is 10 to 15 degrees cooler than the rest of the very hot Sacramento Valley. Nothing to replace. It's just through this process of natural systems, they've created a microclimate that is continuously cooler without replacing any equipment. And I'm going to talk about how it works. What is solar-oriented design or passive solar design? These common sense principles have been around for a long time, and some very wise people throughout history have understood the benefits of orienting homes and structures towards the sun. Passive solar starts with a few basic principles. The sun rises in the east and sets in the west, and is higher in the sky in the summer and lower in the sky in the winter. And one needs to think about the microclimate, and there's also a consistent breeze that you can leverage to help cool your buildings. In response to these simple facts, passive solar design amounts to designing the building shell itself as an energy system, not as a box that has solar panels have a place, but not just a box that relies on advanced technologies and machines to provide the thermal comfort. The building shell itself is providing that thermal comfort. So the design principles, you orient a building, a community to the south, and if you're in the southern hemisphere, to the north. You use a roof to keep the summer sun out and shade the structure from the summer sun, much like Socrates understood. And in our modern buildings, you locate windows on the south side and absorb energy, and you use the roof will shade the building to reduce heat gain in the summer. A passive solar building will provide thermal comfort for the life of the building, requiring little or no cost in maintenance and no parts to replace. Contemporary passive solar buildings consistently provide comfort and reduce energy consumption by 50% to 80% over normal baseline buildings. And that's before you put the solar panels and the other technology. But if you build the shell itself is providing that efficiency, then all the other machines and technologies can be smaller. And lastly, a city that's in Turkey, Perrine, is typical of Greek cities built after 350 BC, that they're oriented to the south. And it's also known, you can also find, like the previous slide, solar-oriented cities are found throughout ancient history and on all continents. So, how did we get here? Too often, urban design begins with projecting a geometric visual construct over nature without considering the pre-existing natural systems on the site and how the sun moves across the site. The surprising history is that the Renaissance invention of linear perspective in 1413 by a single man has a lot to do with it. Linear perspective has influenced art, as we know, and architecture and urban design for the last 600 years. Examples of the paintings of the ideal city, there's 3 in existence, here's 2 of them. These paintings that began as an art exercise really established what in the West we have thought of as a beautiful city. A boulevard with buildings of similar heights on both sides, and a heroic object, church, statue of Napoleon or whoever, at the end of the boulevard. So this movement that started as an art idea has become an idea for beautiful cities. But this idea is disconnected us from nature. And the famous radial design, which we'll talk a bit about, from the 1600s or 1500s. So this has become a popular design motif for urban design. The origins are from the Renaissance preference for geometric order, mixed with a little bit of military need for providing protection on all sides. There are modern examples of communities. Oops, I'm sorry, I'm getting ahead of myself. Technology and low-cost energy extracted from the earth have allowed us to ignore nature. We've turned our backs on solutions that provided thermal comfort and water and other necessities for thousands of years. Here is Disney's Epcot Center. I use this image all the time, not just because I'm in Florida. I just want to say that. Designed from 1963. It was a geometric pattern imposed on nature without concern of Florida's landscape or climate. This vision wasn't constructed, as we know, but if implemented, it would have required much more infrastructure and energy than a city that works with Florida's natural habitat. Abstract geometric patterns disassociated from local habitat require more infrastructure to function and more energy to operate. They are more costly to develop, take more resources, and require more energy over the life of the project. Here's a modern example of lessons learned from Socrates in Greece and China and India. This is this development in Davis, California. Started construction in 1975. So they incorporated the lessons of designing with how the sun moves across the sky and how the water moves across the site. And I show in detail, so they devised a really well-integrated landscape that directs the water and uses it to build a really extraordinary ecosystem that continues to get better today, and it doesn't need to be fixed. It just keeps working. It keeps getting better. Village Homes is a 60-acre planned community of 230 homes, community buildings, and other community amenities that was designed and developed by Judy and Michael Corbett. Village Homes is perhaps the best example of an integrated, regenerative designed community. It is certainly the oldest, now almost 50 years old. Village Homes is an especially valuable example of what works over time. And we are really short of good examples that we can rely on, like this works, it will work in 2070 because it still works. Comparing these two approaches. So in Village Homes, because of the street orientation, 100% of the structures have optimal solar orientation. And I'll show in more detail, but because of the natural planning, there's less infrastructure. On these 60 acres, there are 0 subterranean concrete pipes, which for me represents not just the pipes, but they represent infrastructure that the way we design cities always requires. So Village Homes points a way for how to work with nature to reduce or avoid infrastructure. Versus Epcot Center, which the sites that have optimal solar orientation are highlighted in yellow. Only about a third of the site easily has optimal solar orientation. The Corbett's incorporated lessons from ancient cities to capture seasonal rainfall. Sort of self-explanatory. If interested, one can Google ancient city water capture systems. It's pretty amazing, the variety of things they did. It's really, really amazing. Just as impressive architecture, the dry wells in India, it's sort of obvious. So the picture of village homes, I just want to say that this is not just a path in a beautiful garden, but the path, the swell that's barely visible because of all the vegetation and the trees, that's all part of an integrated water capture system, and an integrated system that creates a microclimate, and it's responsible for why village homes is 10 to 15 degrees cooler in a very hot part of California. I just love this plan. So the stormwater harvesting and integrated landscape design, you get the streets are oriented east and west, but so the streets and the swells between the houses were designed so all the water flows to a series of lakes and lagoons. They're not just retention basins like that we are now required in California, but the water sits there and it goes deeper and deeper into the soil over the years, improving the health of the trees. So some benefits of the system is healthier, more productive fruit trees, increased moisture in the microclimate, helping to reduce summer temperatures. Oh, sorry. I get so excited. And this cycle of water and trees, the soil biomass is pretty extraordinary. And as the soil is transformed over the years with exposure to water, it absorbs more water, so less prone to flooding, which just perpetrates the whole cycle. So this is just a simple landscape that they put into this landscape put in motion an ecology that has transformed the soil and has benefited the community. Some more other benefits. The houses are 50% more energy efficient, and these are houses built in the 70s. They're not tight, they're not sophisticated. It's really cheap construction. Some homes still don't have air conditioning. This part of California was many days over 105 degrees, even in the 80s. So it's really quite extraordinary. Because they didn't have to buy concrete drain pipes, they saved $200,000 that they purchased 300 fruit trees. So it's, for me, a one-on-one. Don't need concrete drain pipes, you buy 300 fruit trees. And these fruit trees and this integrated watering capture is what makes village homes so extraordinary. And so, this is a great example of blue infrastructure. And it's so far outside of what people in California are still designing. I'll get ahead of myself. Anyways, it's pretty extraordinary. Again, the microclimate is 10 to 15 degrees cooler than the rest of the Sacramento Valley. And so expanding a bit, there's too few papers and documentaries about village homes that tell amazing stories about the social benefits. More friends, people getting to know their neighbors, less crime, and one of my favorites is children have a place to play throughout all of the extraordinary landscape. And they talk about there's always fruit in season throughout the year. So they have snacks from the trees while they're playing. And lastly, Jeff Lawton from the Permaculture Research Institute reports never seeing a more productive fruit trees and gardens than village homes. And it's sort of obvious. because it probably is 20 years older than the oldest permaculture gardens. So this continuing of year after year, more water, deeper roots, more water, deeper roots, has created really an extraordinary ecosystem. So Jeff Lawton, who is not a stranger to sustainable agriculture, suggests that village homes should be a UN World Heritage Site. So I'm not the only one who thinks it's quite exceptional. So anyway, concrete drain pipes. This is a concrete pipe not from village homes. But I just love this. Like, you can choose. The future that depends on the left, your left, are the fruit trees. So conventional community design that begins with a geometric order laid over the landscape like a carpet relies on technology and concrete infrastructure to mitigate the effects of natural systems. This infrastructure is designed to resist nature's forces and therefore will always be more expensive and less resilient. Technology makes things work with ongoing maintenance, but it doesn't channel nature's resources to create local abundance. Village homes, on the other hand, offers a model for a regenerative ecology balanced future. Working with nature eliminated the need for the drain pipes, and 200,000 and more was directed to purchasing fruit trees, which continues to rebuild and strengthen the ecology, infinitely more resilient. Over time, the natural cycle of deep watering from the winter rains allowed the roots from the trees to break up the soil and go deeper. And then the next year, the water gets a little bit deeper, and everything moves. Jeff Lawton talks about after 3 years of this system, the earth had more moisture 18 feet down. So it's extraordinary how it works. And this is why the fruit trees produce so much fruit. There's a great video you can Google, Village Homes, America's Forgotten Food Forest. It's sort of great stories, but anyways. Again, we have a choice. Concrete drain pipes or fruit trees. For me, it's sort of that simple. Another example, good old California innovation. This is a project I'm quite familiar with. I've spent time analyzing it, but it's a project in Claremont, California, Meadowood. Shares some similarities with village homes. The streets are oriented east and west, and the site is designed to work with nature. It's a 40-acre development, 90 homes. It's now 36 years old and was designed by Claremont Environmental Design Group, early proponents of regenerative design. And they called it regenerative design in the 70s, California. Like village homes, there is no subterranean concrete drain pipes. It's just really extraordinary. This is no infrastructure. So many benefits, but particularly measuring the total length of linear storm drains on these 40 acres, which are around the perimeter, it's about 28 linear feet versus the adjacent development that's designed and developed in conventional strategies. There's like 130 linear feet of storm drain. So that clearly shows that's 80% of the water on this site is going into the ground. And that savings of infrastructure continues from that site to the ocean. So many benefits of working with nature. Lessons of our time. Nature-based solutions have proven to be more resilient and more efficient for 50 years. They reduce energy consumption and CO2 emissions without machines. These houses maintain comfortable living without air conditioning systems, without that energy, and without having to replace those air conditioning systems. That's like the core of the efficiency. When the building shell itself and the environment around it is well coordinated, many resources can be used for other things. Village Homes offers both lessons on how to design today and provides evidence that nature-based solutions are resilient. It provides a vision for what is possible for 50 years into the future. So working with nature, the sun, the water, but time, we have to think about time. What do we do today and how it evolves in time is really critical. A lover of history. I'm just gonna share a few examples of ancient architecture that embody these principles. Wind catchers from India, which are just pretty cool buildings. Increased natural ventilation to help cool structures without energy. I'm working on an initiative in California that you can incorporate these wind catchers, this sort of strategy, with retrofitting existing buildings, existing concrete uninsulated buildings that, if simple to design and very cost effective, could eliminate the need for air conditioning throughout the world within 30 to 40 miles of a coast. I think kind of a cool idea. So ancient Persian wind cooling towers. Nobody really knows how long they've been around. Ancient Egypt, 2,000 or 3,000 years. But the oldest cooling towers that are still functioning, are still around, that haven't fallen, are 800 years old. And they have required little to no maintenance, repairs or replacement parts, and they still keep the homes cool. As an architect, my favorite things is from ancient Rome. This is they're called the Golden Room, constructed for Nero in 64 CE. It's a large octagon with an oculus that directs the sunlight into 4 different chambers throughout the day. This is beautiful for one thing, but it also provides direct heat in 4 locations in space and time each day. It also elevates the awareness of how the sun changes from morning to evening and season to season. I like to incorporate this sort of thinking in my own architecture. And the cliff dwellings in the Southwest, where the people, I'm sure you've seen these pictures, but they were sort of really careful, and they built dwellings that were protected from the sun in the summer by the cliff above, and allowed this winter sun in. So they positioned these things so that the cliff themselves function like the roof in Socrates' house. So, moving to the future today. So, I'm just going to share a few examples. I have 4 pictures, but there really are 9 examples. And if you want more, so from looking at the Living Building Challenge website, which I think everybody knows what the Living Building Challenge is, sort of the best of the best, the website in 2020, I noticed that only 9 projects out of 111 projects were documented to be more than 50% more efficient than conventional baseline normal buildings. Some were as high as 80% more efficient. These 9 buildings all incorporated passive solar design principles. To me, it's pretty good evidence that it works. Long, narrow buildings east and west, roof overhangs, or other architectural features to reduce summer heat gain, and they incorporated natural ventilation and landscape to provide passive cooling. These principles can work in all climates. These 9 successful buildings are in Hawaii, the humid climate of the Atlantic coast, and colder regions of the Rocky Mountains. Solar-oriented buildings will continue to provide comfort for less energy costs and less maintenance costs for the life of the building. So the part of this building that makes it 80% more efficient, it's good for 100 years. There's nothing to replace for 100 years, which is really good to reducing resources. Solar panels, batteries, and mechanical heating and air conditioning systems have a service life of 20 to 25 years. Low-E glass, which is now kind of so common in our architectural thinking, may only last 10 or 15 years. So why do we accept the limited life expectancy of concrete infrastructure and machines when there are nature-based solutions that are more efficient and require less maintenance and less resources? In contrast, village homes and these contemporary solar-oriented buildings that were designed to work with nature are more efficient and more resilient and more cost-effective to construct and to operate over the life of the projects. Typically buildings, many examples are, well, there aren't enough. But there are some really good examples of buildings that are 80% more efficient that didn't cost anything more to build than a normal building, which obviously clearly has advantages for sort of affordability and this is a passive solar home I designed in Santa Monica, California. It was certified LEED Platinum. Because of its efficiency, we almost didn't make LEED Platinum because of the way we do the numbers, but anyways. The clients have reported to use no energy for thermal comfort. But more importantly, I'm showing this because it provides an example that you can design a high-performing building on a site that doesn't have an ideal solar orientation. If I had $1 for every architect who told me, yeah, I'd love to do it, but you don't have to have you need the right site. No, you don't. You just need a little creativity. So the sawtooth pattern, is kind of a funny plan, is how you make a house on a site that's about 45 degrees off true south work. So not rocket science. As I mentioned earlier, in a passive solar home, and this is, from doing this work, I start to think about this. Like the building shell itself, I've said this many times because it's so important. The building shell itself is an energy system. The windows are in the right place. The roof is designed to keep the summer sun out, let the winter sun in. Some concrete or other thermal mass tubes to act like a battery, and designing for ventilation. So,
this passive solar home
yes?
is more expensive than a regular home.
It's not at all. Okay. So this is the, I'm sorry?
How big is it?
This house is 3,500 square feet. Since you asked, this house was about 5% more expensive, which including the solar panels. There are solar panels, but in theory you need half the number of solar panels. It did not cost more. It did not cost more. And I have my old professor from San Luis Obispo designed a synagogue that, if you want to know more about it, it's an extraordinary example. It's in a warmer part of California than Santa Monica, but so it's a synagogue he built for less money than a normal building, and it's 80% better than normal, and there's no air conditioning system. And he's documented that it's kept cooler than you would otherwise cool a building with air conditioning. So this stuff really works. No air conditioning system. And I just think it's really impressive. Thanks for it. Another building I designed that I'm very proud of. It's an office and an education center for a local water conservation district. A little good news, when we were working on this in 2010 or so, this was only one of 2 agencies in California that were actively involved in recharging the aquifers. Now, 14 or 13 years later, it's actually quite common. Most counties in California are actively recharging the aquifers. So that's just a little good news. But anyway, so this design, I incorporated a cooling tower, the vents on the other side. I'm sorry. So the wind cooling tower plus an interior courtyard, just like the Mediterranean and the Chinese and every other climate in the world. So the combination of a tower and a courtyard with water and vegetation can help cool a building even in a hot part of California. I don't know if you can see it, but there's a large scupper on the one part that projects out 5 feet, which is unusual for scuppers. But it's so the building in many ways talks about water as the importance of water, but also particularly the building entrance echoes the local canyon, which is visible from the site and for many miles around. But this canyon has been responsible for the local topography, and hydrological cycles. So the idea is the building to talk about where water comes from, and that water is a regional issue. I'm sorry. And just one point is that, as I said, so in 2010, the state of California mandated new codes for on-site stormwater retention. Like much of California probably was leading the way to reduce pollution flowing to the ocean. Civil engineers have been developing innovative new infrastructures in response. This water conservation building was in fact designed to demonstrate these new codes. But these standards and technologies do not generate a transformative ecological system as like village homes, as successfully as the integrated design of village homes. So familiar with how the engineering to satisfy California's new codes, but we can do much better. On the inside, so the building its efficiency is pretty good. It's by California standards, what we measure from what we call percent over Title 24, which is not the same as 60% better. But a high-performing building in California is 25% over Title 24, and the building is 60% over Title 24. So yay us. But this is a really important part of when you think about how the sun moves through the sky for the energy efficiency. For me, it's an easy step towards thinking about the sun and how it moves through the sky for beauty. And so on the image on the left, which is sort of obvious, windows high on the tower bring in the last light of the day and change, which I love doing this on buildings. So when you do this, that light from those high windows turns walls yellow and orange. So it's really quite beautiful. I'm almost done. One more picture. A regenerative, ecological, low-carbon future starts by working with nature. There are low-tech, highly relevant lessons to be derived from ancient cities and cultures that well understood the sun moving through the sky and changing from season to season, as well as need to collect and store water. Advanced technology has allowed us to turn our back on nature, but our climate crisis is a warning that it is time to reconnect to nature and to live on Earth by integrating ourselves into natural systems. Thank you. Yes.
Where they're draining all the water into a dry creek bed. Now, is that all being done through gravity, or are they using
no pumps.
No pumps?
When they don't have to use drain pipes, they don't use pumps. So what they worked with is, like in that diagram, they just work with a natural slope.
Now, how big? You know how big that community is?
It's 40 acres and 90 homes.
80?
90.
It's no, because where I live, we tried to do that and it didn't work because instead of draining it into a dry creek bed, they put in concrete pipes, but they didn't connect it to the county's system. Instead, they put holes in the pipe, and they're letting the ground soak up the water. The problem is when it rains too much, that ground gets saturated. So it doesn't soak up.
You need a better architect and a better landscape architect.
Let's continue the conversation. It's very important.
Yeah.
Thank you very much.
I'm sorry?
Thank you very much. Great.
Yeah, they tried an experiment where I live, and that was the problem. That they didn't think it through. So what happens now? It gets really flooded. Often because.
Well, the big lesson is village homes, and I can share. There's a really great documentary about the way the soil works now.
Yeah.
A few years ago, when there was a huge, like 5 inches of rain in
we need to continue our presentation, but you can talk with him. It's really very interesting what he brought. And okay, so 6 p.m. we are going to have our ceremony here, and we have our Naman Sharma. He's Bloomberg Harvard Summer Fellow. He came from Cambridge, and he's going to present Reclaiming City in the Smart City. Naman, please.
Hi, good evening, everyone. Today, this is the last presentation, and I won't hold you too long for the award ceremony. I'm Naman Sharma, and I'm here to speak about my experiences from some of the smart cities that are taking shape 8,000 miles east of Miami in India, and how they are championing the true spirit of smart city. But before that, let us first try to imagine what smart city truly is. Is this the one that measures the activity of each person in real time? Or is it the one that maps the flow of its traffic to streamline movement and avert accidents? Or is it a 15-minute city that is reinventing mobility with autonomous vehicles and ensuring more street space for its people? Or is it the one that is completely reimagining itself by challenging the conventional wisdom of urban planning, transportation, and city making to be the face of future human civilization? Well, all of these questions seem to be true and valid, but the bigger question that is there is what is the commonly accepted definition of a smart city, and can any of the city in the world adopt it? Or is this up to the city to reinvent and reimagine its own definition of a smart city? Well, in my understanding, the picture is not as clear as it could be. And in my research at Harvard, I figured out that the idea of a smart city has turned out to be a misnomer for the public, the government, the policymakers, and planners alike. Originally, this model of new urban utopia promised to put technology in cities to make them more happier, prosperous, and give more opportunities to the public to maximize their creative potential and guaranteed ingenious solutions to address some of the wicked problems in our cities. The central idea of the smart city model was to deploy emerging technologies such as artificial intelligence and Internet of Things to create a physical plus digital network for the continuous flow of data that would enable the city administrators, planners, and policymakers to create data-driven decision-making and evidence-based planning for achieving better outcomes. And at the very peak of the movement, the smart city proponents promised to achieve better outcomes while ushering in a new paradigm shift in the way the business of cities was conducted by leveraging technology. Solutions like smart street lights and sensors for air quality monitoring, etc., quickly became the poster child of this movement. And technology giants like IBM, Cisco, and Alphabet, they stimulated the proliferation of this idea across all scales and geographies in the world, and also led to the investment of huge sums of public and private capital in technology infrastructure. But just after a decade of demonstrating the proofs of concept, the capability of smart city in solving the problems of the cities is being questioned. And especially during the COVID-19 pandemic, it was revealed that the detrimental impacts of diverting the investment from core urban infrastructure to the ubiquitous cloud infrastructure was not a very healthy choice. And it also forced the cities to relook at their investment priorities, while also sparking debate among public about the opportunity cost of these investments in technology solutions, which they initially had hoped that it will create better outcomes for public. And a testament to this misadventure that I would like to call it, came out at the end of 2020 when Cisco decided to shut the operations for Cisco Connect for Cities, which was its flagship smart city service. Although the cities had started their smart city journey with a good intention, but the results were not very impressive to the public. And the aggressive technology-led implementation of the smart city mission was what created some of the problems that were deemed not acceptable by people. And I would also say the detachment of the smart city agenda from the realities of urban problems is what caused or pushed the city to the edge of the smart city. But what is so much to care about the city? Well, in my understanding, a city is not just its road or trains or public spaces or tourism attractions, but most importantly, a city is its people. And these people are the ones who leverage the creative economies of the city, and they create the entire ecosystem where everyone can live, work, and play, and while thrive at the same time. And these people expect far more from their governments and their smart city ideas. And the current ecosystem of smart city has clearly fallen short of their expectations. And considering them as merely data points has pushed them to the edge of the smart city. And some of you might agree with me that calling the current idea or the concept of a smart city as a digital, connected, or even IT city might have been a better choice. However, in India, things look slightly different. And I was part of the Smart Cities mission in India and worked with the national government for 3.5 years. So the mission started in 2015 when the government also, with the global trend, following the global trend, initiated the Smart Cities mission in India, and it was the world's largest deployment mission at that time, which had 100 smart cities under its umbrella. I would like to note that these were not the new cities that were supposed to come up. These were the 100 cities that already existed in India. But the government's priority was to reimagine and reinvent all these 100 cities so that they can become lighthouses of urban development for the rest of the nation and the rest of the world. And as you can see, while the development of technology infrastructure was one of its objectives, the government was quickly able to realize that technology is just a means to an end and not the end itself. And the other objectives of the Smart Cities mission put the community at its core, while aiming for cooperative and competitive federalism. And they also integrated innovation and sustainability within the mission. And finally, they promoted convergence of financial and human capital to achieve better outcomes. And yes. And the key driver of this reinvention of India's approach to smart city is referred to as public sector design. And the policies, administrative processes, fiscal structures, space making, and methods of public service delivery are the objects of public sector design. In India, the 3 tiers of government, the national, state, and city governments collectively redesigned these public sector design objects to give the required creative autonomy to cities for them to become smart cities, but in their own contexts. And I'll illustrate these public sector objects by elaborating on 3 examples. First one is a new implementation agency called Special Purpose Vehicle that was implemented and created in every smart city. So an SPV, or the Special Purpose Vehicle, was a new company that was created in every city with joint equity from the city and the state government, and was solely responsible for implementing all of the smart city projects in the city. Navigating through the very complex government and bureaucratic structures, the SPV model brought a great profound transformation in how cities raise and manage their financial capital, providing ample leeway for them to be entrepreneurial. As a result, the 100 smart cities collectively have completed more than 6,000 projects by investing $13.4 billion in urban development. And while another almost 1,900 projects are due to be completed by the June of next year. The second highly significant change that has been that has been created in Indian cities is augmentation of cities' capacity by having something called as horses for courses. More urban planners and technical experts are now onboarded at the city, state, and national levels. This has enabled a pluralistic view in urban development, which is also resulting in the recognition of the needs of the historically underprivileged and marginalized communities. And Indian cities have also found out that it is essential for city makers and city designers and administrators to introspect and understand their limitations and own biases. And technology and data is actually helping them a lot to confront these biases and to prevent them from jeopardizing communities' need by their plans which do not respond to communities' needs. As a result, the total $21 billion investment in these cities is not just going towards technology implementation, but a lot of other sectors like WASH or governance, smart energy, and PPP or social infrastructure, economic infrastructure, and vibrant public spaces. The pluralistic approach has also brought gamification into the local and national governance. The national government has launched various competitive programs for cities to reinvent the ways in which they do urban development. For example, the challenge called India Cycle for Change Challenge is actually promoting biking in the cities and asking the cities to build appropriate infrastructure for biking. The next one is Streets for People Challenge, which is asking cities to compete for the financial and technical resources to make their cities better for walkability. The Nurturing Neighborhood Challenge is about creating children and caregiver-friendly amenities and infrastructure at the neighborhood level in cities. The Eat Smart Cities Challenge is promoting healthy food habits in the cities by adopting a food systems approach. And finally, the Transport for All Challenge is asking cities to partner and collaborate with their own local startups to address some of their critical transportation problems. And more planning capacity has encouraged cities to abandon the traditional top-down approach to decision-making while also enabling them to collect their community's own needs and then respond to their own challenges in a competition environment where they could also get some recognition for their efforts. And other cities also get to learn from their nearby cities or from cities who are in a similar geographical context. And they are conducting a lot of extensive dialogues with all the collaborators, such as NGOs, civil society, academia, and local technical experts like architects and urban planners, which are enabling them to come up with the solutions which are very, very contextual to each and every city. The third public sector design element is the process that Indian cities have invented, which is being called as test, learn, and scale. And utilizing all these collaborative partners, the cities are trying to pilot some of their innovative ideas before scaling them up to the entire city level. And Placemaking Marathon is one such example where cities are asked to reimagine and reinvent their public spaces with their collaborators and community members and implement these projects in those public spaces in 75 hours straight. This initiative, again, started itself as a pilot project, but has been in 5th or 6th cycle now, and happens every 6 months in India. In this example, as you can see, in the city of Greater Warangal, the city, with its input from the community, finalized a blighted spot in the low-income neighborhood, which they wanted to revitalize. So they came up with a very vibrant public park for kids and their children. And again, the community provided the design input. They also helped the city in implementing the project. And then finally, they also wanted the city to make it permanent. In the next example, in the South Indian city of Coimbatore, the city, again with community, identified the need to figure out some solution for this very, very inorganic junction, which led to a prominent lakefront park. So the city, again with community input and with technical input from agencies like ITDP and WRI, came up with a solution that firstly fixed the geometry of the road and the junction, and then also introduced some vibrant elements to improve walkability and biking in the same junction. till the lakefront park. What is also worth noting is that the cities did not just implemented projects and then they just stopped working, but they also solicited inputs from the communities after implementing the projects. For example, they asked these communities with whom they initially co-created questions like, how much do you think these place-making interventions made sense? So as you can see, mostly people said they really liked them. Then has the intervention improved accessibility to the lakefront park in this particular situation? Most of them, 3/4 said yes. And then finally, if people wanted to make these kind of interventions permanent. So they said yes. So the entire conclusion from this kind of approach was to not go with full scale with a project or an idea into a city that can then be not accepted by people, but first test it out in a small place or at one junction or at one park, and then ask the community if they really like it, and then actually scale it up. So with many similar innovations, India's smart cities have truly championed the spirit of smart city, which is doing more with less. And its foundational pillars are the public sector design and technology, and not only technology. And while they have deployed extensive technology to support the other public design elements, the public design elements are the one that are guiding the journey of smart cities through their entire process. And the smart cities movement in India is led by planners and policymakers and not just by technology vendors, which is making the real difference, I must say. And each of these 100 cities have reinvented their own path to achieve smartness in their city and put the city back into the smart city, which is putting the needs of its people back into the smart city. Yeah. Thank you so much. That's the presentation.
Let's put the award ceremony video, slides.
guess I can use this too. Okay. Hi, everyone. Thanks so much for staying. I know everyone's been here a long time, and I appreciate you staying because it's a very exciting time of this conference to talk about people that have been doing exceptional work in the field of sustainability. This awards presentation is for the who's who in sustainability, and looking over some of the biographies, it's really incredible because people have come from as far as Ukraine, people right here in Miami doing exciting research, incredible technology that's very innovative, and their life's work and mission is to reduce carbon emissions, to come up with new technologies to do that. And the reason that we're here tonight and we're staying this into the evening is because we want to be able to have a chance to let them showcase each person just a few minutes of what it is they're doing. And then afterwards, I'm going to present them with an award that Bernardo has provided. This is really the who's who of sustainability. So for the first person we're going to welcome is Biayna Bogosian, assistant professor at FIU. Her deep water project is a mixed reality experience that offers innovative approach to exploring the complex and pressing issue of urban environmental data. It's an experience that showcases the socio-spatial and political dynamics of the water crisis in the coastal city of Miami, which is grappling with significant changes, as we know, with pollution and sea level rise as a threat. So let's bring to the stage now Biayna.
Thank you. This is an incredible honor, and I'm absolutely excited to be recognized. So this morning I presented a presentation called Exploratory Urban Environmental Media from Awareness to Action. And with this, I concluded the presentation looking at a project called In Deep Water. A little bit about my background if you are just joining. I'm trained as an architectural technologist, but also my PhD focused on spatial media and immersive media. So as part of USC School of Cinematic Arts, I was very much interested in how to introduce engaging ways to think about environmental issues. And at the core of this is looking at environmental data. So learning from cinema, bringing storytelling, as well as technological aspect of working with environmental data and thinking about participants and stakeholders has been at the center of this work. And I've tried to bring as much of that as possible in classrooms that allows me to then work with architectural and other computer science and other fields. And specifically, I moved to Miami 5 years ago, and before moving to Miami to start teaching at FIU, I mainly looked at air pollution as this parameter to start to understand the sociospatial and technical dynamics in different cities. So from city of Shanghai, looking at relationship of air pollution and the way that the government was reporting that, to Seoul, looking at how for a very long time Korea was blaming China for its environmental issues, to city of Mexico City and thinking about how the government pledged to release data even though it's not good data. So starting to look into how to create different engaging methods, from augmented reality to virtual reality, to not only participate in data collection but also information sharing and representation. And at the core of this is the mission to make information more transparent, and along with that begin to create new relationships, which is people to people but also people to information. So an example of that was, for instance, when we looked at Biscayne Bay data of fish kill that happened in 2020, and how by creating, in this case, a website that would allow us to share data from people that were contributing to data collection would allow us to understand correlations between variables such as dissolved oxygen and temperature, and at the same time start to introduce other things such as social media, video for storytelling, but at the same time release the information to the public. So specifically, the project In Deep Water started to collect some of the efforts. So here we're looking at a project called Water Wand, which for the past for years within our lab, this is the Robotics and Digital Fabrication Lab, has allowed us to think about information collection, so creating a device that one could walk with and place it in this case, wherever there's flooding, collect data, but also use an app that not only is visualizing where data collection is happening, but incorporating, in this case, a blockchain technology that would allow us to also make sure that there's trustworthiness, right? And people that are trusting us with their time and data. So specifically, this project in deep water came as a National Science Foundation grant, which pretty much is the reason why our FIU Institute of Environment is operating. And we had a supplement as part of that National Science Foundation grant that focused on how to engage the public. So we started to look into children museums. So we thought about maybe museum in Coral Gables, and they have a program that works with children. However, we realized very soon that if we wanted to create an experience to communicate this information with children, making this information compact, mobile would be quite critical. So we thought about, well, what if we create this map of Miami that unfolds on a table, and you're able to then start to introduce layers. Unfortunately, the pandemic happened, and we were not able to continue our collaboration with the museum. And I had to start to think about, well, maybe we lay out the technology, and eventually we're able to maybe take it to many museums. So this project was created as a way for us to look at an unfolded map of, in this case, downtown Miami, and begin to overlay a three-dimensional map of the city, as well as then other information, such as prediction of how the city will look like when there's flooding. And today, for instance, Professor Spiegelhalter also talked about the flooding data, etc., and how, in some of the visualizations currently, we only show up to 6 feet. What if we increase that to 10 feet? What would that look like? What would that sound like? So using a HoloLens technology, so this is an augmented reality headset, which also allows us to connect to network in real time, we were able to not only load data that were pre-processed, but also connect to, in this case, derm sensors that are gathered or that are distributed along the city. Now, for an experience like this, I think what's really critical to think about is the duration of the experience. So in this case, over time, we realized that people don't want to wear this more than 3-4 minutes. So is it really worth their time to wait for a sensor to be updated every 2 minutes? Maybe not, right? But looking at real-time data and combine that with archival data, we can start to create different maybe types of engagements. Maybe we can appeal to different stakeholders. So this video walks you through the experience, and calling it in deep water. And you begin the experience questionnaire, and this questionnaire also allows you to understand the interface. So for instance, for you to work with a slider that eventually allows you to see the sea levels, we are introducing you to a slider interface. Then you're asked to look at the map. Once you do so, you're faced with a three-dimensional city. We had to create some really interesting computational workflows to really navigate this relationship between the different shaders that we use in augmented reality and resolution of the city. And you're faced with a menu. Imagine this as different GIS layered, or as different tabs that you might want to introduce. And you're able to start with a sea level rise simulation. Unfortunately, it's not a good news. And what you start to see is that after about 20 years, the city is pretty much taken over. Now, the flooding simulation does start from the lower parts. Simulating topography in this scale is quite difficult. However, we really tried our best. And then moving on to other layers. And as we were doing user testing, we realized that maybe some people do want to understand these layers, let's say layer by layer, but some people were really interested in layering this information. So here we're looking at one of the buoys that FIU Institute of Environment is using for data collection. Those are the location of the derm sensors, and those images are being queried from Twitter. So some are maybe more on point than the others. Here we're looking at simulation of the river compared to the bay, and looking at average readings. And of course, this is a framework that's meant to be edited and commented on as people that are using this. And the last experience is the community engagement component. As you're looking at these images, so imagine these might be Google images that might be popping up as you're navigating or roaming around the city. Whichever image you look at using eye gaze tracking, these images are activated and you're able to hear about a story. So the idea here is to incorporate storytelling, but with also data visualization to then create an engaging experience. Thank you very much. Sorry for the duration.
Okay, it is my pleasure to present. Oh yeah, I'm just gonna read it, her name so people can hear me. Biayna Bogosian with this award, and we'll take a picture. All right, for our next speaker, and then we will pass along the next Who's Who in Sustainability Award, is Anna Braverman. The fascinating story. She's the driving force behind EcoWave Power, a company that she co-founded in 2011 with a mission to revolutionize renewable energy. And Anna's personal story is really interesting because she is born in Ukraine, just 300 kilometers from Chernobyl's nuclear disaster, and her life was nearly cut short when she suffered a respiratory arrest and clinical death as a result of this nuclear catastrophe. But she survived. And it's an incredible story that not only did she survive and get a second chance, but she's building this innovative technology, EcoWave Power, which has many achievements. And one of the things that it's noted for is that it has an offshore approach in its technology, avoiding the complexities of costs associated with offshore installations. And EcoWave sounds like a really incredible company. So I don't want to go on too much about it because she'll be talking about it. So thank you so much, Anna. Come on up and we'll get your presentation and your award.
So thank you, everybody. I'll cut it short because I just had my presentation earlier. So I just want to say that I'm extremely proud of what we're doing. I think that EcoWave Power can really become a game changer in the world of renewable energy. As I said before, wave energy on its own can provide up to 66% of all the United States energy needs. And I'm extremely proud being here as I said, as a little girl that, and as Bonnie said, as a little girl that barely survived the Chernobyl disaster and then immigrated to a super small town in Israel. You know, I didn't even travel abroad until I was 21. The only time I went on the airplane was in order to immigrate from Ukraine to Israel, and that's it. So really being here and being a company that is bringing its technology to the United States, we're about to open our first Los Angeles facility, wave energy generation facility, which will be a really, really big step forward for the wave energy industry in the US, and being publicly traded on the NASDAQ here in the US makes me extremely proud. So thank you very much. Thank you. Thank you.
We'll take a picture. All right, incredible story there. For our next award winner for the Who's Who of Sustainability, I would like to introduce Ebru Ozer for her outstanding performance in sustainable nature-based solutions designer. Should be interesting. Looking forward to your presentation, and I'll leave your award right here to give to you.
Thank you so much for this incredible honor. I am going to be accepting this award on behalf of our firm, LandscapeDE with my partner and my husband, Douglas Thompson. All the work I have presented today was done through both of us, through our firm. I think the idea of creating nature-based playgrounds came to our minds when we had our baby. We were living in Brickell neighborhood on a, I think, 45-story apartment building, and we had a very little access to parks and playgrounds in Brickell to really take our child to places to entertain and do something outside the walls. It was not only hard on our child, but also was hard on ourselves, and we were actually taking the trip to Everglades to find nature. And that idea developed through those days and those experiences. We really believe in the power of nature and power of bringing nature into children's lives. Many of us here, based on what I groups, we were very fortunate. We were able to play outdoors. We were able to see nature, experience nature, touch, feel, observe birds, animals, and a lot of species of different plant materials. Our children now, and especially after pandemic, possibly if you have a young one at home, perhaps you observe the number of visits to psychologists, to getting supports from psychological support from professionals. And we really believe in healing power of nature, and we believe that if we bring back nature into the children's life, we will reverse this condition. So thank you so much again for giving us this honor, and we look forward to having you visiting, at least since you are here in Miami, one of our playgrounds. Thank you.
Thank you so much. All right, for our next award winner of Who's Who in Sustainability, Raimondo Rodulfo. He is going to receive this award for his outstanding performance. It sounds like the Academy Awards for Sustainable Technology Innovator. Looking forward to this.
Thank you so much. So, thank you. Okay. So, what I'm going to tell you today, so it's most a story of collaboration and connecting the dots. So basically, over the years, so in my role as the Chief Innovation Officer of City of Coral Gables, one of the main things that I try to do always is connecting the minds, connecting the dots, and finding solutions together, you know, with academia, with industry, with members of the community, listening sometimes to the members of the community that have better ideas than the ones that we are thinking about. And we fit from all of that, and then we come up with solutions. So over the years, we have been building what we call that connected, intelligent infrastructure in the city. At the beginning, what we wanted to do really is to create resiliency, high capacity, high-speed communications, broadband connectivity, digital inclusion for basic services, for 911, for city services, basically to provide public safety and provide mobility, traffic safety. So those were the main goals at that time. I'm talking since 2004, when I joined the city from the industry. I started 30 years ago as an engineer in the telecommunications industry. When I joined the city, that was the priority. Let's build that capacity. Then after years, we started building a layer of cyber-physical systems, connected infrastructure. Now that we have the capacity to connect the environment, to connect the constituents, to connect the services, now let's build that visibility over the environment. And we started deploying things like public Wi-Fi networks throughout the city. We started providing technology like CCTV and ALPR, public safety sensors that help police lower crime more than 40% in just 2 years. And technology for traffic safety that helped lower traffic accidents more than 40% also in that time. And things that helped engineers to improve traffic flow and things like that. And measure carbon emissions. And building visibility over the environment, air quality, water quality, noise pollution. So all those sensors, that capability, we needed also that to be blended with the architecture and with the culture of Coral Gables. So we are called the city beautiful, and that's for a good reason. So we want technology in a certain way to be less disruptive, even though technology in the right of way has a footprint. Cameras and routers and different sensors and systems, even though you can have underground utilities like underground fiber that we have deployed throughout the city, but not everything is underground. So we have the overhead technology, we have smart lightings that they are visible, and we have technology that we need also to be visible because the citizens need to be aware of the technology that is out there. And also how that technology is collecting information from the environment also for civic good. So when we started building that technology over the years, we started now having those challenges. So how do we build that technology, how we implement that technology in a way that is harmonious? Coral Gables was founded 100 years ago by George Merrick as a city coming from the Garden City movement and the City Beautiful movement. Also implemented that Mediterranean revival architecture that inspired George Merrick and the architects that worked with George Merrick at that time. Sometimes we had challenges like we had to paint an antenna so it matches the color of a facade. Things like that, you are always thinking, okay, creative ways to make technology less disruptive, to blend with the environment. Like cities like Barcelona and Paris and London that are historic cities, they have done it. They have done a great job trying to make technology less disruptive. So given that challenge, so one of the things that happened is that after we had all this technology mostly concentrated in the geofence and in those districts that you see there represented in that map, then we started looking at ways how we can make that technology not only gather information about the environment, using that data also for sustainability purposes, helping to build infrastructure for electrification and decarbonization. So thinking on the sustainability side and collaboration of this technology. Tomorrow you will hear from the Assistant Director for Sustainability and Mobility, Matt Anderson. He's going to explain a lot about the Sustainability Master Plan and execution over the years that have helped the city lower carbon footprint, implement a large fleet of electric vehicles, implement electric vehicle charging infrastructure and others in collaboration with our innovation and technology team. And in collaboration with FIU, also and water scientists, we deployed water sensing technologies in city and water canals. So giving all that infrastructure that is helping us to measure those variables from the environment, VOC, CO, CO2, pollutants, and getting all that information fed into a smart city platform that can be used by environmental engineers and by city policymakers. Now we have to look ourselves, how can we make that technology less disruptive itself? How can we lower the footprint of the technology itself? So when we attended a Consumer Electronics Show in Las Vegas in January 2020, right before the pandemic, we were accompanied by our good friends that are here, the researchers and professors from University of Miami, Dr. Sara Roshinek and Dr. Aviv Roshinek, and Alex Gamundi, senior systems analyst from my team, also with our economic development director. So little I knew when I asked Alex to reserve a booth at CES that we were going to be the only city in the US that had a booth at the Consumer Electronics Show. That was kind of like a rarity and attracted a lot of press that was never the intention. But one of the things that we did there was research. So the biggest technology event in the world, and we had to divide and conquer. So Dr. Roshinek, she was feeding me information from the stands. Alex was doing his own research, and we were at the booth. I was working in collaboration with NIST, the National Institute of Standards and Technology, and I couldn't leave the booth as much as I wanted. And it was so big, like an entire city full of technology and a smart city exhibition. So all that information that we were gathering from Dr. Roshinek, from Alex, from economic development, at the end of the conference, we said, okay, what is the most interesting technology that we have seen here? a lot of things, for energy efficiency and many different things. One of the technologies that I liked a lot is this technology that you see in red. It's a modular pole. Why? Because it kind of like answered the question, how can we lower the footprint of smart city furniture, of smart city technology? So that collocation that we have, like public Wi-Fi routers and point-to-point gigabit microwave connectors, and then we have air quality sensors, and then we have smart lighting controllers, and speed sensors, and red light cameras, and license plate reader, and CCTV. So when you start adding, you say, okay, too much technology, that can become technology pollution in the urban landscape and can be disruptive. So this was kind of like an answer in that question, because it's modular, has no attachments, and then we learned it was engineered by aerospace engineers, and it makes a lot of sense. They apply the same modularity that they use for aerospace engineering, or for example, for the ISS, or for a spacecraft, the same modularity that they need for aerospace engineering, they applied it to that smart city furniture. So no attachments, it was modular, it was like a plug and play technology. So I learned that that technology was developed by aerospace engineer that used to work with the European Space Agency, developing a spacecraft, for example, that Saturn Moon spacecraft that was sent by the ESA. So they applied the same technologies. So we got in touch with them and we said, okay, let's do a prototype. So we got the first prototype of that technology, the first in North America, that you see the first picture, and we installed it in our financial district. Why? Because we didn't have, we hadn't still built the cyber-physical network in that area, in that corridor. And we said, okay, let's do the first pilot of this technology using this modular pole. Then, because it's modular, the next picture is the version 2 of the same technology. We didn't have to do construction. It was plug and play. We just replaced all the modules. That was really when you have implemented smart poles or city infrastructure that is connected, you know that construction is maybe the most costly and disruptive part. You have to break ground, you have to pull permits, you have to do a lot of low voltage and high voltage, construction, building, materials, etc. Not having to do that anymore because you have this technology. Also with no attachments, and you have very advanced electronics, microelectronics, and technology that you can, every time they have a new module, it's like having a peripheral in your computer, like a plug and play USB device that you can change anytime that there's a new manufacturer technology that is more efficient. Then, after we had the second version, something that we contributed is that our city manager, for example, is a structural engineer. He helped them, because this technology was developed in Europe, he helped them to re-engineer it for wind loads of Florida. So to survive 175 miles per hour winds, which is category 5 type of winds, and comply with the American Society for Civil Engineers standard 7-10. And my team helped them also to improve some of the internal electronics. And so it was a win-win collaboration between the engineers of Aiking, which is the name of the company. They are headquartered in Germany, and our team. So what was the next phase of that collaboration? At the same time that we were working with Aiking for this prototype, the first in North America, we were working with the Italian design firm Pininfarina, world-renowned, world-class design firm, known for automobile, for Ferraris and Lamborghinis, but also for electronics and for the Coca-Cola vending machine or for the Cisco Catalyst series and many others, architecture too. And so we had a collaboration to try to create a design DNA or a design footprint, blueprint that we can apply to our smart city technology. How can we make it more blending better with the built environment of Coral Gables and the Mediterranean architecture? So we had this project. Those three graphics that you see below that is the next generation of this smart city pole technology that Pininfarina and Aiking and the city, we had an MOU of collaboration. So now we have this new design. So this is the way how the Aiking modular pole technology works. So you see all those different devices that are for different purposes, for traffic safety, And every time they come up with a new matter purpose technology. And working with Pininfarina, so Pininfarina did an industrial design analysis of the city. That's where we also brought another collaboration from University of Miami. So the dean of the School of Architecture, Dean Rodolphe L. Curry, who is a world-renowned expert on blending the built environment with our physical systems and architectural design. He also was an advisor that I invited to help us working with Pininfarina team in that first discovery phase. So this is an example how Pininfarina looked at elements of the architecture of Coral Gables, like you see that Mediterranean, the archways of the Mediterranean revival architecture in Coral Gables. Also design that they have done for electronics and for the industry. And with that first, let me see if I can move. Then they came up with this first design number one. They call it Archway into the Future. They had 6 designs. I'm going to tell you the 3 that were selected by our city. Then they looked, for example, at the Mediterranean columns and the twisted. Also, they got inspired by nature, by the South Florida nature and by coral. And they came up with this other design and by the texture of palm trees. And they came up with this second design, Twisted Macho. Then they looked at, this is a simulation that they sent me recently from Aiken, how, because these poles are being manufactured in Europe now, they are being shipped to our city in the next month. We are currently installing the anchors and the bases. Number 5, overhangs and blossoms. So you see how they draw inspiration from nature and from architecture too, from Coral Gables, but also from the Mediterranean cities in Europe that inspired Coral Gables design in Spain, Italy, and France. Then they came up with this third design that also blends a little bit of that design DNA of our city. And that's rendering showing Miracle Mile, which is one of the main streets in Coral Gables downtown. This is another rendering of that design. This is a rendering that shows a video here. So if you want to learn more about our Smart City projects, I'm going to present tomorrow about some of these research and development collaborations with universities, with scientists and researchers. Tomorrow, I'm going to talk a little bit more about this project, but also about other projects that we do in research with academia and industry. You can find more information in this QR code. It's our Smart City Digital Library. And I want to recognize members of this partnership here. So we have Dr. Sara and Aviv from the University of Miami. Dr. Dean El Curry couldn't attend today. And also we have Paolo Trevisan and Federico Francesconi from Pininfarina also visiting here, and Alex Gamundi from my team. All of them, you know, an important piece in this journey. Thank you.
Two awards for you. This is for your team, and that's for you.
Thank you so much.
First, the team's take a picture. Thanks, Armando. Oh, we can? Okay. In the middle? This is for your team, for the city of Coral Gables.
Ale, do you want to come?
You want to come? It's a great video. Alex? Congratulations. I'll let you guys take it together. Okay.
Thank you so much.
Congratulations.
Thank you.
That was a great presentation. All right, for our final award this early evening, we have for the Who's Who of Sustainability, I'd like to bring up Sara, Pezeshk, I'm sorry if I don't pronounce it right, but Sara is being honored for her outstanding work in sustainable generative design. So thank you, Sara. Oh, I sat across from you at lunch today. So I'll let you do your presentation.
Thank you for this, and I wasn't expecting that, but tomorrow I'm going to be presenting my project, so I think it's, I mean, I know it's very late and we're all tired, so it's maybe easier to watch the quick video I made, and I'm going to be talking about this more in details tomorrow. So this is a part of my doctoral project that I was working in since 2019. Looking at hybrid solution and looking at this, how we can kind of make a more resilient coastal area by integrating gray infrastructure along with green infrastructure. So it's a kind of like a nature-based solution. This is the campus that I was, a BBC campus in Biscayne Bay. That was my site. I was collecting data, so this design, it's data-driven infrastructure, which is kind of using storm surge data map that I was collecting from GIS and including solar radiation, as well as the information about topography, using these algorithmic design to create kind of a landscape that it's responsive to natural, our climatic changes. So the design is a biomimicry inspiration, looking at rock formation along the shoreline. So I was using this algorithmic modular system to create this modular landscape design, which is kind of integrated with natural elements like mangrove trees, salt marsh, and seagrasses. So each, I end up having 4 different typology. As you can see, some of these are holding mangroves, and then some becoming a landscape that can collect water for retention later and clean the water. So it's a multi-purpose landscape, and everything is based on these data collection. This is, for example, a tile that is slanted to collect sedimentation and everything, and also look into material system to kind of create a concrete that is more eco-friendly. We have been doing a lot of tests and doing composition and configuration, and to study how we can kind of reduce the cement ratio in the concrete, and using different type of minerals to capture CO2. I also look into how I can increase the biodiversity by changing the morphology of the texture. So by creating texture formation, I was actually able to collect colonization. These are the tests that I did 2 years ago. I made these tiles to kind of take these tiles and test them along the shoreline. I was using digital fabrication, concrete printing, and a new technology that we were exploring, how we can kind of create something that's more efficient, but as well as sustainable. So this is one of the example of the tiles. I showed this earlier in my presentation, but I'm gonna focus more tomorrow on these. And then these are different techniques that I used for creating molds for these tiles. This is CNC machine. These are all the tools that we have at FIU. So I use our resources. So these are some of the mold making, and thus creating these formwork that it's easily to can be created in the site. These are some of the mold making that I have made, and this is pouring concrete, mixing concrete. So from design to the end of prototyping, this is the process that I used. And these are some of the tiles and actual scale. And some of the tiles are being tested along the shore. So we've been actually this summer was collecting some information, and the result was pretty promising, I would say. So hopefully I'm going to be continuing this project for my postdoctorate. These are the tiles that you can see. So I think this is some of the inspiration is coming from coral, fossil coral, that it's kind of, you can see, and they have this brain coral or honeycomb coral, so the design is also kind of integrated with the local inspiration, basically. Some of these tiles are already been placed, and this is the example of the rendering that hopefully this kind of infrastructure can only bring people in to the nature, and they can use and enjoy their local environment. So that's the idea. This is rendering. This is a simulation, the last one, but the rest was the actual work I was making. That's the video. That's the rendering. Okay. Animation.
Okay, this is for you.
Thank you
beautiful.
Thank you so much. Okay.
Take a picture.
Thank you so much.
All the award winners can come on the stage for a group picture. Anyone with an award, come on.
Three ladies, two men in the award. Four ladies, two men. We won for the first time.
Do you have your award? Oh, you know. Oh, okay.
Yeah.
We have one more. She's getting her. Hold on, one more person's coming in.
Before we start the pictures, I'm going to be in the middle there with Bonnie. I would like to make one announcement. I would like to make an attention, please. Attention, please. I'm going to give also an award for Bonnie. She didn't know about that. And I'm going to give it to her. I don't have the certificate with me now.
Okay.
I give you later. Because of her work talking about sustainability. We need to educate people, and she's doing this very well. So let's go to the picture.
Okay, thank you so much.
Okay? And I'm going to be in the middle.
See everyone tomorrow.
No, tomorrow flying to New York.